Stuart. Stop talking in the back of the room. Oh, see, you're still not looking at me. Oh, there you go. Yeah. How you doing? So hi, I'm Monty Taylor. I'm going to give you a quick intro to Swift, or so they tell me. I might give you a quick intro to something else, and if I do, then that's what you're going to get. And there's nothing you can do about it, really, because I'm the one with the microphone and the little clicker. As a quick overview, it's basically just because I like to brag about myself, of who I am and why I'd be up here talking to you. I currently manage the automation engineering group for Hewlett-Packard, specifically work on developer automation and tooling for OpenStack. So we are the people who, and we're talking about this tomorrow, you should come to the talk, but we're the people who make sure that all of the development process works and is usable by people and force them to use it. And it's really handy in the force them to use it part of that I'm also a project policy board member for OpenStack, so I can help make sure that people do what I tell them to. It doesn't always work. Actually, it rarely works, but that's a whole other thing. Also a core developer on the Drizzle project, which if you didn't know is when we got bought by Sun for $1 billion, and then a couple of us decided to fork it, and then convince Sun to pay us to work on the fork of the thing they just paid $1 billion for. So if you don't know about Drizzle, it's a fun thing, and we like hacking on it. Before that, I was a MySQL cluster and high availability expert, which might be the most relevant part to why I would know anything about Swift, because data storage and whatnot. So anyway, and there's logos on this slide. It's images that makes the slide more fancy and corporate. All right, enough of that. So most importantly, to start off with, Swift turns out it's not RAID. It's not a distributed file system. You can't mount it on your computer. You can't install it on your laptop and use it to. Well, you can mount it on. You can install it on your laptop and use it to store your images and your porn, but not probably as easily as you might like. It is not a CDN. In fact, on its roadmap to-do list is CDN. But that's not to be a CDN, that's to interface sensibly with CDNs. It is also not a SAN or a NAS or anything of that nature. It is not block storage in any way, shape, or form. It is more closely akin to well, what is it? It is object storage. It has a REST API. If you've ever heard of Amazon's S3, that might be, and I don't work for Rackspace anymore, so I think I can say that. It's pretty much the Rackspace version of S3, or the OpenStack version of S3. It also, as S3 is basically Amazon taking something called the ideas behind MogulFS and rewriting it from scratch inexplicably. It's essentially that. So if you've ever heard of MogulFS, which they wrote at LiveJournal to do the exact same tasks, it's essentially MogulFS rewritten in Python, because nobody likes to run Perl servers these days, which is, I believe, the reason that neither Amazon nor Rackspace used Mogul, is they were afraid of Perl. Camels, yeah. Certainly, you can't run large-scale infrastructure like that on Perl. It'd be terrible. Definitely the reason we should make technology decisions. Anyway, I really hope that the Swift team isn't watching this streaming over the internet. But no, I'm really just picking in good fun. We took several of the other pieces of things that they wrote at LiveJournal and rewrote them in different languages because we didn't want to write them in Perl, Hi, Memcache, and Gearman. So it's not like it's a totally dead idea. I'm talking about that way too much. Sorry, I digress. So Swift is really good for a couple of types of use cases. Like I said, it's not good for it's not good for being a block storage device because it's not one. It is really good for backups because you can just splat a whole bunch of stuff onto a Swift deployment and then ignore it, which is pretty much what you're always going to do with your backups. It's also really good for web content. So lots of little small things that you're going to write once or maybe a couple times, but probably just once, and then you're going to read ready. My gosh, you're going to ready that many times. That's just embarrassing. All right, well, we're going to ignore that. In terms of scale, and this is where me picking on people for not just using Mogul possibly be just me being an ass and not actually being accurate, Swift does scale really big. I mean, there is a central MySQL database tracker inside of Mogul, which most of the time doesn't get overworked, but at a certain scale that is going to get overworked. Swift does power Rackspace Cloud files. The version that you download from the website in the tarball is literally what's running Rackspace Cloud files. Actually, to the chagrin of the release management team at OpenStack sometimes, because we've sort of got this release cadence thing that we're going on, and the Swift team working on Rackspace Cloud files release the software when they've installed it into production. And that happens when they install software into production, when they need to install software into production. So they don't really feel like waiting 4 or 5 months for our next release cycle. Again, I digress. But it has many servers and many users. I would tell you how many, but they don't. A, I don't know. B, if I knew, I wouldn't be allowed to tell you because they're really protective of that knowledge for some reason. I don't really know why, but there's many things that I don't know in life, and that's one of them. There are other people that are also using Swift. I also don't know who they are because they don't tell us. But apparently lots of people are using it. At least some people other than Rackspace are using it. Rackspace is using it at massive scale. I think it is fair enough to say that it is fairly massive scale of, it's probably a larger scale than what you're thinking of deploying locally, is how big their deployment is, unless you happen to be Amazon. And if you happen to be Amazon and you're thinking about deploying Swift, that's really cool. So you should probably jump right on that bandwagon because open source and open standards are good things, guys. People like people who do that more. Anyway, like AT&T apparently, who's now going to be jumping on the bandwagon. We learned in a webinar the other day, whatever. I'm digressing again. So other people are using it. Okay, I don't think I can say that. So at the core of the Swift design, as most things that need to scale largely, is to try and keep things simple. So simple is better than complex, being an adage from Python development, actually. I should mention Swift is development in Python, not Perl. But simple is better than complex attempts to pervade the sort of Swift design philosophy. And the other one, which we all know, is that at a large enough scale, everything breaks all the time. It's all broken. Statistically, all of your shit will be broken right now if you're at a large enough scale. So trying to keep that in mind rather than assuming that any of the piece of the puzzle is ever safe or not going to break, because it will break. So there's essentially 4 parts, even though some of these parts have subparts, but we're going to call them 4 parts because that's what we're going to do. There's essentially 4 parts to Swift. There's the proxy server or servers, there's the ring, storage servers, and consistency servers. And the last bullet point we're not going to talk about as much as the others, just because. The proxy server, even though it's called the proxy server, is essentially the API server. So this is the thing, it's the public face of Swift. It's the thing that you're going to talk to. It sits there, you send it REST calls, and it does stuff. And then it takes the responses from stuff, and it sends those responses back to you. API server. They call it proxy server. I didn't get to pick. Turns out I'm not a core developer on Swift. I probably still wouldn't have gotten to pick because it actually also is a proxy server, so we'll ignore that part. I'm just really in a mood today. Anyway, so that's part number 1. That's what you talk to. That's where the API is implemented. The ring is where things get interesting. The ring isn't a ring. The ring used to be a ring, but that got boring. But we still call it the ring, even though it's not a ring. The ring is a mapping of partitions to volumes, and when we're talking about partitions here, essentially inside of the ring mapping is information about. So if you have an individual file that you're gonna, or an individual object, it doesn't have to be a file. Suppose it's a file. Everything's a file. This is Linux.conf. It's Unix. Everything's a file. It's not Unix. It's *Nix. It's Linux. Damn it. I've just violated AT&T copyright, I'm sure. Again. I'm digressing, I'm sorry. So MD5 sum, of course, has bits, and you decide how many, what's that? Ring power.
A big D card for you.
Yeah, sorry. It contains the ring power of how many of the MD5 bits to use, which is what we're going to call the partition. And it's the mapping then of, given a chunk of bits of MD5, what volume, what server that volume, where that volume is going to be. So it's a static mapping of those things. Also, what replica? What replica? That doesn't make any sense. It's how many replicas of a particular in a particular ring we should have when we replicate stuff out. The reason that the Swift ring is not amongst the reasons the Swift ring is no longer, the Swift ring started off as a consistent hashing ring, which is the reason it's called the ring. It stopped being a consistent hashing ring because it turns out that when you start doing multiple availability zones, it's really difficult to deal with a single consistent hashing ring across multiple data centers in multiple locations, which is where the static mapping part came back in. A big caveat, not that we're talking at all in the 15 minutes that I'm up here about how to set up Swift, because that's just not going to happen. You really can't change the ring power in the ring ever at the moment. It's really, really difficult. You can set up a new ring in a new availability zone and start migrating data to it, but if you want to size that, you need to size that for the size you're expecting your zone to be. So get that one right at the beginning. And there's actually multiple rings. There's rings for accounts, containers, and objects. And the way that hangs together is there's accounts, which is like me, right? I've got an account. Within that account, I have one or more containers, which sort of like a folder, but we're going to call it a container. And then inside of each of those containers, you have one or more objects. So they're sort of gradations of how we're going to manage things. So we have separate rings for all of those. But they're not a ring. The Swift storage servers then is where imagine this, stuff gets stored. It's where the data actually lives. We have different types of storage servers, account, container, and object, because I was just talking about how we got the those different elements. So we got different servers to hold all of those things. On the account and container server, which you might imagine are a little bit more like metadata, since they're just holding location information, there's a SQLite database. And you might say to yourself, wow, I thought you said this thing scaled to enormous sizes. How could you possibly do that with a SQLite database? And that's because it's a SQLite database per server, which the ring already knows how to get you to. So you have, you have exactly one server's worth of data being managed by the metadata in a SQLite database, which is probably about the amount of data that a SQLite database can manage. So as you expand out and add more servers, you have more SQLite databases that are only accessed by the local server. So on the one hand, it causes the drizzle MySQL side of me in my background to go, oh my gosh, you're doing what in production with what? It's actually not the world's worst idea. But anyway, so that maps the containers and the objects back into the accounts, and there's one per server. And then there's the ones that actually store. I said that they were where your data gets stored. These are actually, again, metadata servers. But you've got your object storage, which amazingly enough, you use a file system to store files.
You're crazy.
And they use a local file system to store files locally on the thing. So it doesn't use a weird pile of blocks and store it there. It just sticks files in file systems. And this is actually the directory structure. You've got a mount point and a data directory. So I guess you don't technically have to have a mount point and a data directory. It could just be mounted off of root, but that would be weird. Anyway, so then you've got the partition, which we were talking about earlier, which is in the ring how many bits of the MD5 of the object you're going to partition on. So you're going to have a directory for each one of those partitions. The rest of the hash is going to go there, and then you're going to have the hash itself, and then you're going to have the object plus a timestamp, just to make sure. In case you happen to get MD5 collisions, which is technically possible. Yes?
What goes into the extended attributes?
What?
What goes into the extended attributes?
No idea.
Okay.
Sorry.
All right.
You see, now you're getting down into the lower level. I have no idea. See, damn it! You asked me a question. You're not supposed to ask questions. I'm supposed to talk as long as we get to the end, and then we just go get beer later on. And
That's politics.
Oh, damn it. Okay. So that's how that works. The caveat to this, and this is, I'm guessing, where Xouter is apparently deficient in some way, is your directory metadata can actually exhaust your RAM. According to John, I don't have any specific information on that, and I apologize for that. But I thought it was a warning, so I thought I'd include it anyway. Probably so. I think that's why it's the word can and not will. And then, like I said, we're not going to talk about these very much, just because they're less interesting. Is the consistency servers, but these are so you're going to have the one. This is again. So there's a couple of pieces of the Swift architecture where people go, "Wow, why are you doing that?" The rsync nature of the replicators is one of those. So the replicators sit there and they check the storage servers, the objects in the storage servers, and see, oh well, this is supposed to have 3 copies over here, and it doesn't, so I'll fix that, right? Well, these rsync to do that, because it turns out, end of the day, rsync is actually really good at the task of shuffling data around and synchronizing it between servers. So again, I'm going to, so sorry they didn't write their own algorithm in Python to do that by hand, which is really awful of them. I mean, it shrinks the amount of yes. No, you're going to ask me another question. That's terrible. No, none for you. Okay, go ahead.
I'm just wondering, does that mean if I say I want 3 copies of my data, that means that all the data on one server is on 2 others? Like, is the async taking the entire data set from the machine and replicating it?
I believe so, yeah.
File level.
Yeah, it's because what you want to make sure is, so the hashing is to make sure that we're distributing the data, but since we're not actually doing the consistent hash. We're 5 minutes. Great.
5 minutes or until AM is.
Until what?
It's either 5 minutes
or until
within 5 minutes if AM hasn't walked into the room. So
well, I don't see. Oh, see now my fate is based on Aryan. That's terrifying. All right. That's anyway. So yeah. The rsync is to make sure. Basically, we're going to write to one of the servers that's in the partition pool for the thing, and the rsync is just to make sure that the other servers that are associated with that. So the replicator is going to look into the ring, right, to figure out which volume servers want this chunk of data, and then make sure that they have it. So after a failure, if a new one comes up, you can move things over, or if it's just been written, it's gonna do that. But so it's basically gonna write and then rsync rather than try and do that in a. Anyway, does that make some amount of sense?
Does that mean that in my writing stack, there's no guarantee it's on 3 machines?
I don't know the answer to that question. Actually, that's an interesting question. I know that the replicators are more for like long-term maintenance of the thing. What's that?
As far as I know.
Yeah, I don't believe it's
strictly asynchronous.
Yeah, I don't believe that I believe similar to S3. I don't believe that you're getting I mean, there's certainly not a 2-phase sort of write like we've written everywhere sort of situation. Whether it's trying, I think it actually does punt all the way back to just to the rsync replicators and let them do. Basically write it and then let it discover that there's a thing that it doesn't know about, and then copy that to the places that they need to copy it to. Pretty sure, but dancing around that a little bit because yes, you're talking now. Good, talk.
Would there be any way to disable rsync if I'm already using a lower level file system that's already capable of that replication intrinsically? Yeah,
turn on replicas to 1. Like in the ring config, you're going to tell it how many replicas of a particular object you want replicated out. So just tell it you want 1 and rely on your lower level thing. In theory, in bracket, rsync is probably still going to run and discover that you have 1 copy and that you're happy. But yeah. And then honestly, I have no idea what the updaters and auditors do because they didn't tell me that. That is the 10-minute virtual lightning talk version of getting started with Swift. The best place for information, honestly, to get anything about Swift is to pop onto Freenode and into hash OpenStack, and John Dickinson, who's on there as not my name, will almost always answer any questions that you have about Swift, unless you don't live in his time zones, in which case he won't, because he'll be asleep. But that's a different thing. The code is we do releases of Swift on Launchpad. The code gets mirrored to GitHub, although that's not its canonical location. I just have to say that again. And you're more than welcome to email me on the times that I don't know the answer to your question. I certainly know who does, which is where I actually become useful. So what?
I found an answer to the question about what's stored in X adders.
Ooh, excellent.
Whatever you want.
Oh, that's right. Yes, because you can. Yes, thank you. I actually did know the answer to that now that you've said those words out loud. Yeah. So in case you didn't hear Jim, when you pass a blob of data when you upload a blob of data into Swift, you can associate as many key value pairs as you want to with the data as metadata, and it uses xadders to store those rather than an extra phantom file or something like that. So, thank you. I didn't know that. That's crazy. All right. Any other questions that I can try and avoid answering?
One last really difficult question.
And Aryan's here.
In that case, thank you, Monty.
Excellent. Thank you.